This is our fifth video of solid state. In previous video, we have completed packing efficiency and the relation between A and R. Okay, today we will discuss next topic, that is closed packed structure. This is very important, and if you will not concentrate in the video seriously, then it would be difficult for you to understand the topic. Okay, because this topic can be easily explained or understand in three-dimensional way. Okay, but here I am using mobile phone, so on mobile phone to draw the three-dimensional structure is not possible. So if you will concentrate, then you can understand it. So closed packed structure mean, as you know that in solid state particles are tightly packed, no space between them. But what is the pattern of their packing? Okay, so there are three types of packing. First is one dimension, second is two dimensional, and third is the three dimensional. Okay, we will discuss three types of packing. One dimension mean in which you will follow the single dimension, that is, for example, you are following this pattern, that is only one axis. Okay, that this is only x axis. Okay, so in x axis one sphere is touched with the second, and second is touched with third, fourth, fifth, so on. Okay, so this line is increasing from left to right, that is in one direction. So this type of packing is known as one dimension packing. So what is the coordination number? What is the coordination number? Some students were thinking what is the coordination number, because they did not study carefully in the class 11. So this is the problem. So coordination number mean how many spheres are directly linked with the single sphere. Okay, for example, if I talk about this sphere, so how many spheres are directly linked? This one and this one. So coordination number is 2. Okay, so what will be the coordination number in packing of one dimension? You will say 2. Is it clear to all? You can check any sphere except first and last. Okay, because some ion will be here, some ion will be here, so again coordination number will be 2. But you can consider this one, you can consider this one. Okay, so 2 sphere are there, so coordination number of this sphere is 2. For example, this one 1 and 2. Okay, so coordination number is 2. Now two dimension. In two dimension we will use two type of axes, that is axis x and y. Here this is x axis and this is y axis. Okay, so one layer is this, and we placed another layer over the just below the first layer, so we are getting this type of pattern. Okay, so this type of packing is also known as square close packing. What is known as square close packing in two dimension? So again, if you will consider the coordination number, okay, so how many spheres are directly linked? This one, this one, this one, and this one. This sphere is not linked with this, because as you are looking, there is a gap, there is a gap, there is a gap, there is a gap. So these ions, these spheres, which one? These spheres will not be in the coordination number of the center sphere. So how many sphere? 1, 2, 3 and 4. So in two dimension, if packing is square close packing, coordination number will be 4. And just because of this 4, it is a square close packed structure. Is it clear? So this may be the question in your exam. It may be in the fill in the blanks. What is the coordination number in square close packing? If packing is two dimensional, you will say 4. Okay, because in two dimensional packing, one type of possibility is also there, because we are using two axes. For example, x axis, and I have two method to put the sphere on y axis. First, I can put the sphere just below the first layer. Okay, for example, you are saying layer A, so it will be again A, no change in the pattern. And second type of packing is that as you are putting this one as the first layer, layer A, you can put another layer, just group the between two sphere, ये जो आपके बीच में गैप से हैं, ठीक है ना, इनके बीच में. Okay, similarly third layer is this one. So this is A, this is B, but if you will check again, this, it is just below the this one, so it is again A. As you are looking here, layer A, this is also A, Okay, and what is this? This is layer B and this is layer again B, because these two layers are aligned with each other. Okay, but layer B, the sphere of layer B are aligned with each other. So here are two types of layer A, layer B, and in square close packing A, here AB, AB, AB. Okay, so AB, AB, AB in 2 dimension represent the hexagonal close packing. How hexagonal close packing? When you will check the coordination number of the center, then you will get 6 sphere are directly linked with the center sphere, and these are representing a hexagonal. That's why this type of packing is known as hexagonal, and the coordination number is 4. Okay, so what is here? What is here? As you will merge these sphere, then you will get a square. Okay, that's why this is known as square close packing. Coordination number is 4. Here coordination number is 6 because packing is hexagonal. Okay, I hope you have understand the 2-dimensional packing. Now come to the 3-dimensional packing. This is very, very important. 3D packing. Okay, understand very carefully, students. This is the most important topic and difficult to understand. Okay, so students, this is layer A. Okay, this is layer A, and I am putting another layer just below the groups of layer A. Okay, so in what will happen in the 3 dimension, I will put another layer over this layer. So I am changing the color. Okay, now I am putting another layer. Here 2 types of void are there. Void mean gap. Okay, first whose peak is upside, like this one, look here, this one, and second whose peak is downside, this one. Okay, this one. Is it clear? So now what will I do? Sorry, again I have to draw sphere of first layer, sphere of first layer, second sphere of second layer, this one. Okay, these are not exact spherical. Now I am putting another sphere, this one, like this. Okay, like this. So students, what did you observe? What is void? Void is the free space. Okay, so what did you observe? Over blue or sky blue sphere, this one, you got another void, this one. This is void or not? Okay, so I am drawing separately. How? This is that sphere, back side, this one, and over this sphere 3 sphere, first and second and third. Okay, like this, first, second and 3. You got a void. Clear? So I am roughing it, and one more thing you have to understand here. Look here, look these 3 void, this one and this one. Okay, this one, and now 3 sphere of back side. Which one? This and this one. Okay, so what did you observe? I am again drawing separately. You observed one sphere in the center when you are arranging the sphere in 3 dimension. Okay, and 3 sphere, first, second and 3, you got a void. Okay, and in second pattern, when 3 void are here, and again you put three sphere here, then what did you observe? Then this void is as it is. Okay, this is not covered by the any sphere. Okay, so there are two types of void are originated here. This type of void is known as tetrahedral void. This is known as tetrahedral, and this is known as octahedral. This void is known as what? Octahedral void. Why this is tetrahedral? Because when you will go for the coordination number, its coordination number is 4. How coordination number is 4? 1 is the blue sphere and 3 is the red sphere. So coordination number is 4 and its coordination number is 6. Whose coordination number? void के coordination number की मैं बात कर रहा हूं, जो गैप है बीच में. इस गैप से 6 sphere are directly attached. 3 are red, 3 are sky blue. So coordination number is 6. Now observe in this diagram. Okay, you will understand here carefully. This is layer A. Okay, I am considering layer A, and when I put layer B over layer A, so there are two types of void. First, this one, as you are looking, this void is formed over the layer A, sphere of the layer A. This sphere is the sphere of layer A. Okay, first thing. Second thing, this void is remain as it is, and this void is covered with the 6 sphere. 3 are dark, these 1, 2, 3, and 3 are dotted black. 3 are dotted black. Okay, so we have two types of void. Okay, students, so we are going to discuss two method by which you can form two structure. First, understand carefully. First, I am drawing these dotted, black dotted sphere. Okay, black dotted sphere. 3 and 3 are these dark. Okay, this one, and this one, and in between these 6 sphere there is a gap, and this gap, this one here. Okay, this void is known as what? Octahedral void. Students, when you will put another layer over here, so you observed 3 type of layer. First, layer A, second, layer B, and third, this sphere. Is it clear? Again, I am explaining how. First layer is this one. I am saying layer A. Second is black color dotted, layer B, and third I am putting here to cover the void C. That is octahedral void. What is octahedral void? Which is surrounded by the 6 sphere. Is it clear? So there is a pattern of 3 type of layer. Layer A, layer B, layer C. And this type of crystal is known as cubic close packing. Cubic close packing. So students, 4 questions are there. First, you will understand very, very carefully. I mean, this may be the question in your exam. First, what is the pattern of layer in cubic close packing? So you will say ABC, ABC, ABC. Because why I am saying ABC, ABC? When you will put another layer, then it will follow the pattern of layer A, then B, C. It will be the repeated pattern. ABC, ABC, ABC. It is clear? First thing. Second question is that what is the coordination number in cubic close packing in 3 dimensions? So students, here I cannot count the sphere on the mobile phone, but in 3 dimension way, if you will calculate the number of sphere which is surrounded by another layer, it will be 12. You will keep in mind that coordination number in cubic close packing, it is 12. So 2 questions are there. First is what is the pattern of layer? You will say in cubic close packing ABC, ABC, ABC. Second thing, what is the coordination number? You will say 12. In 3 dimension. I am talking about 3 dimension, not in 1 dimension and not in 2 dimension. Okay, and third very, very important question is that what fraction in this packing is tightly packed? कितना proportion यहाँ पर packed है. So packing efficiency here it is 74%. Okay students, I told you about 4 questions. First is what is the pattern of layer? You will say ABC, ABC, ABC. Okay, in cubic close packing you will write 4 things. First is pattern of layer ABC, ABC, ABC. Coordination number 12. Packing efficiency 74%. It is clear or not? And this is formed by when we placed another sphere over the octahedral void. Okay, over the octahedral void. Okay, and so you will give me the answer in comment box. What is octahedral void? What is the coordination number in octahedral void? Okay, what is octahedral void and what is the coordination number of octahedral void? I will check in the comment box. You can reverse the video if you want to listen the answer. Okay, second thing, with the help of octahedral void, what kind of packing you can form? So you will say when we placed another layer over the octahedral void, we will get the ABC ABC pattern having the coordination number 12 and packing efficiency is 74%. Mean we will get the CCP packing. Okay students. So students, you will give the 3 answer. Okay, what is CCP packing? In which the pattern of layer is ABC, 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 and it is formed when octahedral void is covered by the another layer. Third, coordination number in cubic close packing is 12. Second, packing efficiency in cubic close packing is 74%. Okay, what is octahedral void? Which is formed by the 6 sphere. Okay, 3 like this and 3 like this. Okay, this void is surrounded by the 6 sphere. Okay, now come to the another method in which we can place another layer. So students, you are looking this void, gray color void, sphere, sorry, not void, and these 3 sphere over the gray color void. Then you observed a void that is A. Is it clear? So here this type of void is known as tetrahedral void because it is surrounded by the 4 sphere. First is the gray color void. Second is 3 black colored void. Is it clear? So this is known as tetrahedral void. So consider gray color void as layer A and 3 black colored void, sphere as B. If you will place another layer, I am changing the color. If you will place another layer over this void, so what will you observe? You are placing a void which is similar to the layer A. जो बिल्कुल इसके पीछे हमने ये बनाई थी बिल्कुल उस जैसा है कि नहीं है. So in this case you observed only 2 types of layer. Layer A, that is this one, and layer B, black color void. Okay, and again you will observe the layer A to cover the void A. Is it clear? So again you will consider 3 questions. First very important point is that what is tetrahedral void, which is surrounded by the 4 sphere. Okay. Second question is that what type of packing is known as in which the pattern of layer is AB AB. So you will say this is known as hexagonal close packing. And what type of packing is known as in which pattern of layer is ABC ABC? You will say cubic close packing. It is clear? Second question, what is the coordination number in hexagonal packing? Same 12. Same 12 mean it was in cubic close packing also. What percentage is packed? So 74% packing will be the in hexagonal close packing like cubic close packing. Okay, so there is a 2 difference only. First, pattern of layer, and this pattern of layer in HCP is known as ABAB, and in cubic close packing it is ABC ABC ABC. Okay, and it is formed with the help when you cover the tetrahedral void by another layer, then you get the hexagonal close packing. In cubic close packing you observed the cubic close packing when you placed another layer over octahedral void. Student, this is very, very important. So next topic we will discuss tomorrow. It is sufficient for you. Thank you. In which the pattern of layer is ABC, 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 and it is formed when octahedral void is covered by the another layer. Third, coordination number in cubic close packing is 12. Second, packing efficiency in cubic close packing is 74%. Okay, what is octahedral void? Which is formed by the 6 sphere. Okay, 3 like this and 3 like this. Okay, this void is surrounded by the 6 sphere. Okay, now come to the another method in which we can place another layer. So students, you are looking this void, gray color void, sphere, sorry, not void, and these three sphere over the gray color void. Then you observed a void that is A. Is it clear? So here this type of void is known as tetrahedral void because it is surrounded by the 4 sphere. First is the gray color void, second is 3 black colored void. Is it clear? So this is known as tetrahedral void. So consider gray color void as layer A and 3 black colored void, sphere as B. If you will place another layer, I am changing the color. If you will place another layer over this void, so what will you observe? You are placing a void which is similar to the layer A. जो बिल्कुल इसके पीछे हमने ये बनाई थी बिल्कुल उस जैसा है कि नहीं है. So in this case you observed only 2 types of layer. Layer A, that is this one, and layer B, black color void. Okay, and again you will observe the layer A to cover the void A. Is it clear? So again you will consider 3 questions. First very, very important point is that what is tetrahedral void, which is surrounded by the 4 sphere. Okay. Second question is that what type of packing is known as in which the pattern of layer is AB, AB. So you will say this is known as hexagonal close packing. And what type of packing is known as in which pattern of layer is ABC, ABC? You will say cubic close packing. It is clear? Second question, what is the coordination number in hexagonal packing? Same 12. Same 12 mean it was in cubic close packing also. What percentage is packed? So 74% packing will be the in hexagonal close packing like cubic close packing. Okay, so there is a 2 difference only. First, pattern of layer, and this pattern of layer in HCP is known as ABAB, and in cubic close packing it is ABC, ABC, ABC. Okay, and it is formed with the help when you covered the tetrahedral void by another layer, then you get the hexagonal close packing. In cubic close packing you observed the cubic close packing when you placed another layer over octahedral void. Student, this is very, very important. So next topic we will discuss tomorrow. It is sufficient for you. Thank you.